Hello. In this video today, we're going to study force vectors um, through an application. How to calculate the components of vectors, how to use Newton's second law in order to determine the force in this system. So let me start by explaining the setup right here. So right here we have the ceiling of a room, and on that ceiling I anchored two cables at point A and at point B, and I have a big disco ball right here with an anchor at point C. The mass of that disco ball is 10 kilogram. The horizontal distance between A and B is 10 feet. The vertical distance between A and C is 3 feet, therefore it's also the vertical distance between A and C. And the horizontal distance between C and B is 6 feet, which also tells us that since this is 10 feet and this is 6 feet, the horizontal distance between A and C would be 4 feet. Okay? So the idea in this problem will be to calculate the force in this cable and in this cable based on what we have right here. And knowing this will allow us to find the correct cable, the correct dimension for it. Okay? So the idea in this kind of situations is to first create a free body diagram. The free body diagram, we're going to create it for this part, but we're going to really represent it by the point C. So what kind of forces do we have at the point C? So I'm going to draw my little centroid right here. We're going to have the weight of the disco ball, and it's not falling down because it's held in place by those two cables. Therefore, we're going to draw the cable right here. So I'm going to have the force right here. I can name it whatever I want. I could call it force 1, I could call it force 2. I'm just going to call it the force BC, right? Because it's between the point B and the point C. And I'm going to have the force right here. I'm going to call it the force AC. How do I know it goes in this direction and it goes in this direction? Well, the weight is always going to be in a downward vertical direction, right? And the disco ball, we want it to be suspended in the air. That means we don't want it to fall down. That means something has to counteract this. So it's going to go in an upward direction for sure. And since the force is going to be transmitted in that cable, it will be upward and to the right for this one, and it will be upward and to the left for this one. Okay? So we have those three forces for the free body diagram. Now, the next thing we're going to need in any kind of problems involving vectors is we're going to need to define a system of coordinates in order to create, to find the components of those vectors. Okay, so we want to talk about components of vectors, and in order to do so, we need a system of coordinates. So the very classic system is going to have an horizontal axis that we call the x-axis and a vertical axis that we call the y-axis. It's going to be an orthogonal system, it's going to be even an orthonormal system, but it can be really anything for what we need. Right? So now that we have this, let's try to see if we can find the component of these vectors. So let's start with an easy one. Let's start with the vector W. So the vector W is a straight up and down vector. That means that it's not going to the right and to the left. That means that in the x direction, the vector W is going to be equal to 0. Also, the vector W is going to go straight down. Now, direction of the y-axis, the way I drew it right here, is going up, which tells me that since W is going down, it's going to be negative in nature. Okay. Now, W, the weight, is always going to be equal to the mass times the acceleration. So if you have a mass that is provided in kilogram, which is the case in this problem, then G will have a magnitude equal to 9.8 meters per second square. And if you have a mass that is given in pounds, then you are going to use 32 feet per second square. Okay. So here I'm going to use this value for G, and since the mass is 10 times 9.8, I'm going to have negative 98 newtons right here. Okay, so in the x direction W is 0 newton, in the y direction it's negative 98 newtons. Okay, now let's look at the force BC. So for the components of the vector, it's going to be a little bit more difficult because we're going to have a component in the x direction and a component in the y direction. And if I draw it like this, the x direction will be positive, the y direction will be positive as well. So I know that both of them will be positive, but I really don't know anything else about it. So what I'd like to know here is this angle right here. Let's call it the angle alpha. In order to find this angle alpha, I need to use a little bit of trigonometry. I'm going to go back to the setup right here. We know that this is a distance of 3 feet and this is a distance of 6 feet. That means that this angle alpha right here is going to be defined as tangent alpha equal 3 over 6, which is equal to 1 over 2. Okay? Remember, tangent is the opposite side over the adjacent side. Which tells me also that if this is 3 and 6, I can say that this is 1 and 2 as well, which means that the cosine alpha is going to be the adjacent right here over the hypotenuse. And if I consider this triangle right here, with the 1 right here and the 2 right here, the hypotenuse using the Pythagorean theorem will be a square root of 5. Therefore, cosine alpha will be 2 root 5 over 5. Okay, 2 over root 5 adjacent over hypotenuse, which is 2 root 5 over 5. And the sine of the angle alpha is going to be 1 over root 5, which is root 5 over 5. Why do I want these values right here instead of decimal? I could use decimal values, but I'd rather work with this kind of things, and at the end when I have a final numerical calculation, use those values on my calculator. Okay? Because if I change this into a decimal value right here, I'm going to make a tiny error. And if I propagate this error throughout my problem, throughout the processes, then at the end that error is going to be significant. Okay? So I know cosine and I know sine. Why does that matter? Well, let's go back to this right here. For any vector, the components will be the magnitude of the vector times the cosine of the angle in the x direction, and the magnitude of the vector times the sine of the angle in the y direction. Okay. This BC right here is not the distance between B and C. It's the magnitude of the vector BC in my little nomenclature right here. Okay. So do I know BC right here? No, I don't. That's one of the things we're looking for. So all I'm going to do is I'm going to write that since BC right here is unknown, but the cosine of the angle is known, it's right here. Then I'm going to write 2 root 5 over 5 times BC. And right here I'm just going to write root 5 over 5 times BC. Okay. I'm going to do this all over again for the vector AC. So let's see what we can do right here. Now, if I look at my picture, I see that the vector FAC right here is going to the left. Look at the arrow. It's going to the left. Therefore, the x component will be in a negative direction, and it's still going up, so the y component is going to be in a positive direction. Okay? And I will need to know this angle right here. Let's call it the angle beta. Now, if you recall, we knew that this was 4 and this was 3. Therefore, if you use a Pythagorean theorem, or maybe you recognize that this is a 3, 4, 5 triangle, you see that in that case, the cosine will be 4 over 5 and the sine will be 3 over 5. Okay? If the numbers don't work out nicely like they do here, use your calculator by all means. So what are we going to have here? We're going to have negative cosine 4 over 5 times AC and positive 3 over 5 times AC. So I have all my components here of the vectors. Okay? Some of them are known right here. Some of them are not, but I did what I could within what was given to me. So that's the second aspect of this process, finding the components. The third aspect is going to be the fact that we are in a state of static equilibrium. This disco ball is not moving, therefore we're going to use Newton's second law and say that the sum of the forces in the x direction will be equal to 0. The sum of the forces in the x direction is equal to 0. And we're going to say that the sum of the forces in the y direction is also equal to 0. Okay. So what forces do we have in the x direction? Well, we have the vector W, we have the vector BC, we have the vector AC, and they all add up to being 0. That's static equilibrium. And this equation involving vectors, we can apply it in x direction, it's going to be 0, and in a y direction. So the vector W in the x direction, if you recall, was 0. The vector BC in the y direction, in x direction, let me look, was BC cosine alpha. So it was BC times cosine alpha, which was 2 root 5 over 5. 2 root 5 over 5. And the vector AC was negative 4 over 5 AC. That's in the x direction. In the y direction, the vector W was negative 98. For the vector BC, it was root 5 over 5 BC. And in the y direction, AC was 3 over 5 AC. So at this point, what do we have? We have two equations with two variables. The first variable being AC, the second variable being AC. So I'm going to call this equation 1, and I'm going to call this equation 2. At this point, what we have to do is solve a system of two equations with two variables. So you can use whatever method you want. I'm going to use a substitution method here, and we'll go from there. Okay. So in equation 1, I'm going to start by multiplying both sides by 5. That way I don't have a denominator that can be pesky. So it's going to give me 2 root 5 BC minus 4AC equals 0. And then I'm going to put this negative 4AC on the other side, and then divide by 4, giving me that AC is equal to root 5 over 2 BC. Okay, I went too fast, forgive me, verify it yourself. Then what I'm going to do is I'm going to take this result and I'm going to substitute it in equation number 2. Okay, so in equation number 2 I have negative 98 plus root 5 over 5 BC plus 3 over 5 AC. But instead of AC, I'm going to write this. So it's going to be root 5 over 2 BC, and all of this will be equal to 0. So now I have one equation with one variable. It should not be too difficult to solve. So it's going to be root 5 over 5 plus 3 root 5 over 10 BC equal 98, which means that BC will be equal to 98 divided by root 5 over 5 plus 3 root 5 over 10. And it's going to be in Newton. So at this point it's just a calculator problem. Okay. So 98 divided by square root of 5 divided by 5 square root of 5 divided by 5 plus 3 times the square root of 5 divided by 10. So we get 87.65 newtons. Okay. So BC is equal to 87.65 newtons. And if I want to find AC, I just multiply this number by square root of 5 over 2. So let's go back there, and I'm going to multiply this by the square root of 5 divided by 2, giving me 98. So that is for AC. Okay, newtons. So this force right here, this AC equal 98 Newton, is the force transmitted in the cable AC, and the force BC will be 87.65 newtons. Why is knowing those two values important? Well, it's because this is going to allow you to, based on a given material, determine the thickness of the cable so that everything is safe. Okay? We are not going to go into that at this point. This is just an example on how to calculate those values.